This is lesson 9.5, page 583. This lesson is entitled Factor x squared plus bx plus c. I'm going to give this lesson a second name because the name I have is another way of saying this. I'm having you factor a second degree trinomial. Can you see that with what I have written here? That's a second degree trinomial. Now from lesson 9.2, you learned that when you double distribute, let me write this out, x times x is x squared. You'd have an x times 4, which is 4x. You have a 3 times x, which is 3x. And you have a 3 times 4, which is going to be 12. That when you double distribute, you're going to get here. Okay? We use the complete reverse process to factor a problem like this. Okay? And you can see that here in the box below. To factor x squared plus bx plus c, this is what we need to do. We need to figure out what two numbers can I multiply together to get c, but those same two numbers add up to b. As you look at that, you might be like, Mr. Lemancy, I don't understand what the heck you just said. It's a lot easier for me to show numerically. So let me actually show you with what we did here, okay? Let's take x squared plus 7x plus 12. Let me erase all this. Let me cross it out and pretend that we never saw that. I want to factor this. So here's what this is trying to tell me. What two numbers can I multiply together that give me 12, but those same two numbers add up to 7? Well, let me think. 4 times 3 definitely gives me 12. 4 plus 3 gives me 7. So the correct factoring should be x plus 4, x plus 3. And the reason I have 4 and 3 is you can see those are the numbers I created when I multiplied to get 12 and added to get 7. So let me erase what I have. You notice that's what I started with. Now I wrote mine in a reverse order. That's okay. I'm multiplying. I can write it in a reverse order, but there's the proper factoring. That's what this box is telling you to do. Okay? Look at the second sample. I want to factor x squared plus 5x plus 6. So I'm thinking, what times what is 6, but those same two numbers add up to 5? Well, it's pretty easy. 3 times 2 is 6. 3 plus 2 is 5. That's why the correct factoring would be x plus 3, x plus 2, which you see right here. Okay, so factoring a trinomial of second degree should be pretty simple to do. And you notice we're factoring trinomials that have a lead coefficient of 1. So if the lead coefficient is 1, these should be a piece of cake for the most part. Let's look at this sample. Factor x squared plus 11x plus 18. Now you notice everything is positive in this problem. Those should be really pretty basic. I have to think, what times what's 18 but adds up to 11? Well, 9 times 2 is 18. 9 plus 2 is 11. So my factoring is x plus 9, x plus 2. Okay, and you can see I'm getting 9 and 2 because that's the combination that multiplies to 18 and adds to 11. All right, so if I did double distribute, I'd get right back to my trinomial. Now, if your mental math is strong, it's going to make this process a lot easier. I'm not going to lie to you. If you are weak in mental math and you're using your calculator all the time to figure out the combinations, it's just going to take you a little longer. All right? That's just, the better you are at mental math, the easier it's going to make this process. Let's have you try. Pause the video and try these 3. And I'm back, and this first trinomial, well, 2 times 1 is 2, and 2 plus 1 is 3, so it's a 2-1 combination, x plus 2, x plus 1. Here, 5 times 2 is 10, 5 plus 2 is 7. It's got to be a 5-2 combination, a plus 5, a plus 2. Here, 7 times 2 is 14, 7 plus 2 is 9. It's got to be a t plus 7, t plus 2 combination. Now, when you are factoring a trinomial, consider the signs, because the signs, if you look before you start figuring out the combinations, it can save you some work. So let's talk about that. If you have a trinomial, like we did up here, and B and C are positive, then P and Q have to be positive. So this is what that means. You notice on these problems, this is B, this is C, here's B, here's C, here's B, here's C. B and C were always positive. That means P and Q, can you see my P and Q? These numbers represent my P and Q. Those are going to be positive. So this is just saying, if my original trinomial is all positive, my factoring is going to be all positive. Here's the second case. If B is negative and C is positive, so let me color code that up above. If I see B negative, which here's an example of B negative, and C is positive, here's an example of C is positive, that means P and Q would both have to be negative. So let me give you an example of that here. For example, negative 2 times negative 3 is positive 6, but negative 2 plus negative 3 is negative 5. My correct combination here is a negative 2, negative 3 combination. So my factoring would be x minus 2, x minus 3. That would be the correct factoring for that particular example. And that's what this is saying. If B is negative, C is positive, it's going to be 2 negatives in my factoring. And then here's the final situation. C is negative. If you see a problem where C is negative, let me highlight an example of that. I'll do it here in yellow. Here's a problem where C is negative. That means that I'm going to have one number negative, one number positive. I just got to figure it out. So let's take a look at this. I know negative 3 times positive 2 is negative 6. Negative 3 plus 2 equals negative 1. And can you see how I'd have a negative 1 here in the middle? So my correct factoring for this particular problem would be x minus 3, x plus 2. So if you look at the signs of your trinomial, that can help speed up the process. Like, let's take a look at this problem. N squared minus 6n plus 8. This is the second situation. B is negative, here's B, C is positive. So I know I'm going to have 2 negatives in my factoring. So negative 4 times negative 2 is positive 8. Negative 4 plus negative 2 equals negative 6. My factoring should be x minus 4, x minus 2. And again, the better you are at your mental math, the quicker this process is going to go. Okay? Here's another one. Let's do one more. Let me move this down. Let's factor this problem. Y squared plus 2y minus 15. I noticed right away C is negative. That means I'm going to have one negative number in my factoring, one positive number. So I just got to think about my combinations. Well, positive 5 times negative 3 would give me negative 15. Positive 5 plus negative 3 gives me positive 2, which you can see here. So the correct factoring would have to be y plus 5, y minus 3 for this particular problem. Okay? Again, the better you are with your mental math, the quicker this is going to go. If you have to do trial and error to guess through the different factors, it's going to slow you down. I can't, there's nothing I can do to fix that. It's going to slow you down, okay? Let's pause the video and have you try these questions. Okay, and here's the proper factoring for these. I notice C positive and B negative. I'm going to have 2 negatives in my factoring. Well, negative 3 times negative 1 is 3, but negative 3 plus negative 1 is negative 4. There is the proper factoring. For number 5, negative 6 times negative 2 is 12. Negative 6 plus negative 2 is negative 8. This is the same kind of problem as the previous problem. When B is negative and C is positive, I know I'm going to get two negatives in my factoring. Now in number 6, do you notice how C is negative? That means I'm going to have one positive and one negative number in my factoring. So 5 times negative 4 is negative 20, but 5 plus negative 4 gives me 1 in the middle. There's the proper factoring, m plus 5, m minus 4. And that same situation pops up here. I have C is negative, so I'm going to have one negative factor, one positive. 8 times negative 2 is negative 16. 8 plus negative 2 is 6 in the middle. There's the proper factoring, W plus 8, W minus 2. Now, when you go to solve a polynomial equation, now remember, a polynomial equation means that we're going to have something typically higher than first degree. Okay? Whenever you have a second degree equation like you do here, anything higher than first degree, so second degree or higher, here's the first thing you always have to do. You probably ought to get this in your notes. Anytime we have second degree equation or higher, get all terms on one side and make sure you have 0 on the other side. So when you look at this problem, I don't have 0 on the other side. So step 1, take away 18 from each side, which you see that statement here, which gets us this. Now, I have to factor this. So I got to figure out what times what's negative 18, but adds up to 3 in the middle. Well, remember, if C is negative, I'm going to have one negative, one positive. Positive 6 times negative 3 is negative 18, but positive 6 plus negative 3 is 3 in the middle. So the correct factoring is x plus 6, x minus 3. And now this gets us back to what you learned in lesson 9.4. You can use the zero product property. Okay? One of these two have to equal 0 if we're multiplying and getting 0. So for x plus 6 to equal 0, I could take away 6 from each side, and x would equal negative 6. That's one root. Or x minus 3 has to equal 0. If I add 3 to each side, x would equal 3. There's the second root. So the roots are negative 6 and negative 3. Let's go ahead and have you try this question. Okay, I'm back. Do you notice, first of all, we got to get 24 on the left, so we have 0 on the right. So my first step is to make sure that I have followed this direction. And you can see I'm doing that. I'm making sure I'm taking away 24 from each side. Now I have to factor. Do you notice how C is negative? That means I'm going to have one negative and one positive factor. So negative 6 times positive 4 is negative 24. Negative 6 plus 4 is negative 2. There's the correct factoring. I'll circle it in blue. And now, one of these two, since I'm multiplying and getting 0, one of these two have to equal 0. Well, to make this 0, S would be 6. To make this 0, S would be negative 4. To wrap up the video, solve a multi-step problem. You are making banners to hang during School Spirit Week. Each banner requires 16.5 feet of felt and will be cut as shown. Find the width. Now, they're going to start off with both banners together. We want to find the width of a banner, so we're going to have to know area. So if we put both banners together, if the first banner is 16.5 square feet of felt, and so's the second one, when you put them together, you have 33 square feet of felt. And remember, area is length times width. So you can see they took the two banners, they put them together, and you can see now my area is 33. My length is 4 plus W plus 4, which they have written here, and then my width is W. Now, let me simplify that a little bit. Instead of having 4 plus W plus 4, I would have 33 equals W plus 8 times W. I'm going to distribute. Next step. I can't solve this unless I have 0 on one side of the problem, so I'll take away 33 from each side. And when I do that, I'm going to get right to here. Now I have to factor. Do you notice C is negative? So what times what's negative 33 and adds up to 8? Now remember, if C is negative, one of these factors have to be negative, one has to be positive. Well, I'm thinking real quick. I know 11 times negative 3 is negative 33, but 11 plus negative 3 is 8, which matches my values here. So my factoring would be W plus 11, W minus 3, and that would equal 0. One of these have to equal 0. So for W plus 11 to equal 0, if I just take away 11, one width could be negative 11. Well, that doesn't make sense. I can't have a negative width, so that's called an extraneous solution. It's mathematically correct, but it's not real, so I'm going to get rid of that one. My other solution, W minus 3 is 0. If I quickly add 3 to each side, my second solution is W equals 3. So the width of the banner must be 3 feet. I'm going to pause the video here. If you have questions, make sure you ask during class.